let's just do exercise 4 and 5 in one go. So exercise 4 says to get the battery level. So navigator.get battery .then .log. That gives us hopefully something, if that's actually the correct one. So that gives us a battery manager. We want to print out the battery level, so we just, if I can find the code. So we can just do, alright, well, b.level, and then we don't actually need to return a promise to chain on these things. We can just do this, level, console.log, level, and we should hopefully just get the battery level printed out. After we've gotten the battery level, we should fetch some movies, and we can do it from this API here. Copy. And then make sure to convert it to JSON. And then we can log out movies. So like this. So very important thing to notice here is that we're using chaining to say we want the battery level. And once we have gotten the battery level, we want to start loading the movies, not before that. It's very important for exercise 4. Really the key of exercise 4 is controlling when do these things happen in compared to other. Because exercise 5 is actually forcing them to load in parallel. And the way we do that is that we create a promise for a battery. And we still want the level of that one. So we can do this just fine. And we want one for the movies. Fetch. Don't I have that somewhere? There we go. Like Windows, if you show something, please make sure to insert it. Nope. It's like, I have this thing right here. No, you don't. So fetch movies. So now we have both of those. If we want both of them to run in parallel, and we only want the response.
You missed something. You need to continue fetching the movies.
Oh yeah, I need to do the JSON. Good catch. And then we can just put in both of the promises here. Called then. That gives us an array of results, which if we just log out results, we should be able to see that. So important thing here to notice is that they arrive at the exact same time, whereas here they arrive with the batteries first explicitly. So it's a very important to learn from this is the order in which things load. Because being able to control that is very important, so you don't send too many network requests at the same time, for example, but also not too few. Because if you're always waiting for your network request one at a time, starting up a process could take a really long time. But if you're sending too many at the time, you might be overloading the server. And sometimes you need the result of one request to the next. As we saw with the last week exercise that we technically did this time. So for the docs, we need the result of one of them in the next one. And in that case, it's very important to guarantee the order in which they run, because we can't really use the result before we have it, which makes sense when you say it. But being able to guarantee that we get the result, the one before the other, is what this exercise is about. So yes, I think that was all for today. Unless you want to see a very quick demo of something called async await that makes this a bit easier. So I hope that the guys in Copenhagen are not going to kill me for showing you this. So Let's take exercise 4 because that really shows some of the power of async await. So to do async await, I'm not going to give you a whole deep introduction to this, but you create something, you mark it with async function, and then my function. In that, you can do what is called async await code. So we can do const b is equal to await that thing. And then we can do console.log b.level. So that's these two. And then we want to make the network request. Const res is equal to await fetch that thing. Const movies is equal to res.json. Await that stuff. I cannot do it like that. And then we can log out. Come on. Really tired. Movies, please and thank you. So if we just format this up a bit. So notice how this looks almost like normal code. We do one thing, then we do something else, and then we do another thing, and then we wait for that to happen, and then we do the last thing. And this should still write things out in the correct order. So it does the battery level and then the movies. But I mean, this is considerably easier to read, isn't it? So the important thing here is, because this function is marked as async, we can use await. And await work with anything that has a then function, technically, which is called thenables, but mostly promises normally. So whenever we have a promise, we can technically await it. If I don't have this, you'll see that it'll tell me like, you cannot use this because you're not in an async function, and Chrome will probably yell at me. So async await is only valid in an async function. So like, all right. So now if I do this after my a function, what do you think is written first? This or this?
I think it's
The first one, the last one after my function.
Yeah.
So the first.
Yes, exactly. Because this function is async. So it starts the function and then it hits the first of these await points, and I'm just like, all right, sure. We'll wait for that to happen, and then we'll continue doing some other code meanwhile. We can do that just fine. That's really what JavaScript is about, being async. So like, well, how would we wait for this? Well, this returns a promise. So guess what? We can call then on it. Yay. And like if we're just now doing crazy things with promises, we have something called the JavaScript event loop. So we have when we click when we do our code, and then the page can actually work before they trigger our code again. Promises and set timeout also have this, but they are slightly different. So imagine we have a set timeout with a wait of 0. So immediately. Well, not quite, but almost. So first. So which of these do you think? What will be written first? Yes, second. Because this will delay it for 0 milliseconds, but it will delay it until after other things has happened. So second, first. Now comes the question. So like this is really tricky, and almost no one knows the answer to this.
Vi gør opmærksom på, at biblioteket overgår til selvbetjening om 5 minutter.
How do you think it will print out first, third, and second?
The library's unstaffed opening hours will start in 5 minutes.
And let's make it even more confusing. So fourth and fifth. So now I think I have probably confused you. So let's actually move these up so they're just somewhat correct. So this would be first, second, third, fourth, fifth, sixth, I think it's called. So, what do you think this will write out? Or to make it a bit simpler to remember the things.
First 6. Which is 4.
Yeah. So far you're correct. First 1 and then 6.
Of course.
But what will happen first, the set timeout or the promises?
Let's sit down.
I'll go for promise.
I think I'm going for promises as well.
Yeah. So the promises, if this is following the specification, should actually happen first. So 3 and 5. And the reason why this happens is because JavaScript technically has, the way this event loop works is that you have 2 queues of things that waits to happen. So the page starts, it runs your code. Some things are queued up. For example, set timeout is queued to happen. But so is the promise. The thing is that these are actually 2 different queues. Set timeout happens in the event queue, and promise happens in what is called the micro queue. And the micro queue is always resolved before the normal queue is.
That's what this.
That's why. And you can't use that knowledge for anything, but
Yeah.
it's fun, in my opinion, to know that these things are not just as they seem.
Yeah.
So.